Problem 4M1. This is similar to 4L, just it asks you to do a few more things. First of all, it says find the coordinates of the point of intersection with the y-axis. We haven't done this before. There's two ways to do this. One is you could just use algebra, and so like we're working on this first one here, number 1. So if we took x squared plus 2x minus 3, and we want to know the y-intercept, that's basically like saying, what is y if x is 0? So we put 0 in for all the x's, and we get 0 plus 0 minus 3, and the answer is negative 3. You remember in the investigation, whenever you have the plus c at the end, the c kind of says where the parabola intersects the y-axis. And we could do this on the calculator too. Go into y equals again. We're going to turn that one off, and we're going to turn this one on. And we're going to put x squared plus 2x minus 3, x squared plus 2x minus 3, and we're going to graph it. And they want to know what the y-axis intercept is. It's right there, as we can see. Now to see this, the easiest way to do it is do trace. And we push trace and it's pointed right at it. Okay, but of course, you know, if so let's say we weren't there at the beginning, what you can do is you can say, okay, well, I want to know x equals 0. So you just hit 0, enter, and then it puts you right there. So x equals 0, y equals negative 3. So the y-intercept is negative 3. Okay, so that's that. Part 2, the equation of the axis of symmetry. And we know that it's the equation which is on the formula sheet is x equals negative b over 2a. B is 2, and a is 1. Now when you have x squared, it looks like it's not being multiplied times any coefficient, but that's basically the same thing as multiplying times 1. So a equals 1 in this case. So negative b would be negative 2 divided by 2a, and a is 1, so 2a is 2. So negative 2 divided by 2 is negative 1. So the answer would be x equals negative 1. Okay, x equals negative 1. You can't just say negative 1 because this is the equation for a line, so you need to say x equals negative 1. Part 3, the coordinates of the vertex. The x-coordinate we already know because we just figured out the equation for the line of symmetry. X equals negative 1, so x is negative 1. What would be y for the vertex? Well, there's two ways to do it. One is you could substitute the negative 1 into this formula, and then you would get negative 1 squared plus 2 times negative 1 minus 3. The other way you could do it is you could look at the graph. You've already graphed it. We're looking at it right here. And we could use the function second calc to figure out what the minimum of this is. So the lowest point of this parabola happens to be the vertex. So we'll go second calc, and we'll go to minimum. And if you had an upside down parabola, you would use maximum. And you would specify 1 point on the left side of the vertex, 1 point on the right side of the vertex, to tell it which minimum you're looking for. And the reason why you have to do this is because the calculator uses algorithm to estimate it. So the algorithm starts by looking at the left and right side and finding a point somewhere in between. Is your guess 0, negative 3? That's fine. It doesn't really matter what you put for the guess. And so the minimum is negative 1.00001, y equals negative 4. This is an estimate, so that's why it doesn't come out exactly right. But this is negative 1.0001 is the same thing as negative 1. So the vertex is at negative 1, comma, negative 4. Okay, so you get the same answer as when you do it by hand. Coordinates of the point of intersection with the x-axis. So there's two ways to do this. One is you can use the calculator, and you just use the second calc, and we're looking for 0. 0. Okay, so what you're going to do is you're going to go, I'm going to first say, okay, what about this intersection here? We can see where the intersection is. We can kind of estimate what the value is from these little hash marks, but we'll figure out more precisely what it is. So we can see, okay, as your guess, negative 2.55, sure. So it's negative 3 comma 0. So one of them is negative 3 comma 0, and we write that down here. And the other one is over here, which looks like it's about 1 comma 0, but we're not sure exactly how much. Okay, so we're going to do the same thing again. We'll go second calc, and we go to 0. And we're going to do the same thing on this side. Okay, I'm not going to do that because I've already shown you that a couple times. I'm going to show you the other way to do it, which is to use polysmlt. Okay, so you go apps, polysmlt, enter, number 1, poly root finder. It's a second order equation, so you leave that as 2. And we're going to put in the coefficients here, and the coefficients are, it's A is 1, B is 2, and C is negative 3. So I put 1, 2, and negative 3. We solve. And so there's two roots, one is negative 3 and one is 1. So those are the x-intersects. And so we didn't figure out the second one, but from the graph we could kind of see if it was 1. So we put those two. So if we had gone ahead and done it with the graph, we would have seen the same thing. Remember, this is actually 1 comma 0. Okay. Another way to do it is, since in math studies we use a lot of whole numbers, you might be able to just do second table, and it'll give you values on the parabola, and then we can see that, look, 1 comma 0, or the x value of 1 yields a y value of 0, so that would be an x-intercept. And then we would find the other one here at negative 3 comma 0. So through the table you can also see when the parabola is going to be y equals 0. Okay, that doesn't always work if you don't have integers for the points. Let's see, the last thing is part 5, the range of f. Okay, so the best way to see this is through the graph. So the range would be like, what is the range of y values you can get? And so you could see, remember the vertex is at negative 1 comma negative 4. So the y value, the lowest y value possible is negative 4, and it would be anything above that. So we would just say, well, y is going to be greater than or equal to negative 4. That's our range. Remember domain and range. Domain is what is the range of x values. Y is what is the range of y values. Sketch the graph of the function. Well, we have the graph like there, and we already have a few points. One way you could do that is you could use, let's see, that's part B. Okay. So one way you could do that is you could just copy it kind of from the calculator, right? And you know that the vertex is negative 1 comma 4, so you put a point there, okay? And then you know that the x-intercepts, for example, are at negative 3 and positive 1, so you can put those there, right? Okay. So you already know those 3 points. Once you know those 3 points, you can pretty much sketch it, right? And here, let's say that this is the x and y axis. Okay? So then you would get the sketch, okay? The other way you could do it is you could take x values like negative 3, negative 2, negative 1, 0, and 1, and you substitute them into the formula for y, or for f of x, and you would get values for y that would correspond to those. So negative 3 corresponds to 0. Negative 2 corresponds to negative 3, and you could like graph each of those points, and then you would be able to even make a better drawing than that. But if you have 3 points, you can already pretty much sketch it. Okay, and then it says use your GDC to draw the graph to check your results. Well, we already did because we used our GDC to do a lot of this here. Okay.